Hello everyone, this is James Shore with another how-to video. I'm recording this on January 18th, 2016. In this chapter, we are hooking up our tab library to our actual little sample production application. And in the last episode, we finished doing that, but unfortunately, there was a bug. When we click between tabs, we get an error. Rather than things clicking back and forth, we get a JavaScript error. It says could not find default in list. So in this episode, what we're going to look at is what do you do when TDD fails? As I've mentioned in the past, test-driven development is not going to guarantee bug-free code. It is a way of it is part of a package of things that you can do to get very close to zero bug code or bug that has so few defects that it's acceptable for your application. And depending on how life or money critical your application is, determines how hard you work on that. It can help you get towards defect-free code, but on its own, test-driven development does not guarantee bug-free code. What test-driven development does, because of that red-green refactor cycle, it does a very good job of helping you make sure that what you wrote is what you intended to write. I categorize defects into 4 categories. There's the errors that occur when you intend to write something but do it wrong. There's the errors that occur due to having defect-prone designs. I think it was Barry Beam that said that 80% of the or 20% of the modules in an application tend to be responsible for 80% of the defects. So defects can occur just from making a mistake when you're coding, getting the algorithm wrong. Can be due to having bad design. It can be due to a misunderstanding what needs to be done. And it can be due to just systemic blind spots. This is the kinds of things that result in security errors. Nobody knew that something needed to be done, and so it wasn't done. So test-driven development is good at helping you make sure that you wrote what you intended to write, and it can be good at helping you create good design so that you'd have less error-prone designs. But it can't help you do things that you didn't know you needed to do. And I think this bug falls into that category. So what do you do when you have a defect in your test-driven development? And also, how do you ensure that you actually do write defect-free code? If bugs can occur even if you're doing TDD, what do you do to stop it? Well, that is a big topic. And I have an essay about how do you create close to defect-free code. How do you prevent defects if TDD alone isn't enough? And you can find that here at this link on your screen. But there's a sequence of steps that you can follow when you do find a bug that will help you get closer to defect-free code. And here's what they are. Now, you don't have to do all of these. For some of you, this may look like overkill because you don't actually care about defect-free code, and that's fine. But if you want to get really close to defect-free code, which I do recommend because actually doing this stuff, because bugs are so expensive to find and fix, it's actually cheaper to have defect-free code than to go searching for bugs whenever they occur. So here's how to do it. First, when you have a defect, figure out what went wrong. So figure out how to reproduce it, and then go find whatever the source of the bug is. Find the bad code. Second, reproduce that bug with a targeted test. So what you're going to do is write the test that you should have written if you'd known that this was going to be a problem. Then, and then of course fix the bug. So now you have test-driven the bug fix. But don't stop there, because there's probably something else going on here. Defects tend to come in clumps. So that if you found a defect, there is probably another defect close by. So at this point, check out the design of your code. Is there anything about the design of your code that makes defects of this kind more likely? And if there are, refactor your design to make those sorts of defects harder to occur, make them less likely, make the code easier to understand. So first, find the bad code, then reproduce and fix the bug with a test, then fix the design, because most of your programming bugs are going to be due to poor design, and then do root cause analysis. Ask yourself, why did we have this bug? What is it that we did here that resulted in this bug occurring? And there's multiple ways of doing root cause analysis, but one of the easiest ways that I like to use, that I just sort of do in my own head, is 5 whys. So ask, why did we have this bug? And then you say, well, why did that happen? And then why did that happen? And keep on going. And the secret to 5 whys is not to say, oh, because I'm dumb, or because, Joe is dumb, or Sarah's dumb, or somebody else on the team is dumb. Don't make it about the people. Ask yourself, what about the way we work? How do our work habits result in bugs? So in 5 whys, stay focused on process, not people. And then finally, you can do exploratory testing for related bugs. So assume that if you had this kind of bug, it's because of a blind spot in the way you've worked, and there are probably other bugs that are also in this blind spot. Similarly to the way design can result in clusters of bugs, not really thinking things through in a particular way can result in bugs that are related to that problem. So exploratory testing is a sort of ad hoc testing approach that is more sophisticated than I have time to get into right now. You can do a Google search for it if you like. But essentially is about using your experience and intuition to create test scripts on the fly and execute them. And if you don't know how to do that, you can just try using the application a little bit, searching around more in the area where the bug is. So those are your 5 steps for when a bug occurs. If you use this kind of process and this kind of thinking in all your work, you're going to be less likely to have bugs. You cannot get to 0 bugs, but you can get to a low enough bug count that fixing them is fairly inexpensive and that your productivity stays high. You keep going quickly. Okay, let's get to it. We want to use this sequence of steps for our bugs. So first, let's find the bad code. So what we're getting this could not find default in list when we click. So obviously we've done something wrong related to our clicks. Let's go ahead and look at our code. If you'll recall, this works by first initializing. Then we say handle click. So it's a good guess that there's something wrong in this code. And then we say show tab. So there could be something wrong in this code too. Really, there's not a lot of code here. It could be anywhere. But for me, I think one thing I notice is that this message could not find default in list. That's not very helpful. For one thing, it's not the defaults that's the problem. So let's go ahead and improve this code to be more readable. Let's say that we could not find tab to show, or really, let's see. Yeah, let's say we could not find tab to show. Let's call this find index still works. This let's rename to tab to show. And let's actually put in the tab that we're going to show. So the tab we're going to show is a DOM element, and DOM elements, we can actually dump out the whole element like this by saying outer HTML. If we do that, hopefully our fail fast code will be more readable, help us figure out this problem more easily. So let's try that. We'll run it, reload, and then when we click, could not find tab to show, tab 2. Tab 3, tab 1. So what I'm noticing here is that the tabs that we're supposed to show are actually a little bit different than that. It's saying it can't find this, but really what's supposed to be shown, what we have in our list is this. So if we go back to our tabs and we look at show tab, we're finding the index on option.tabs and tabs to show. Tab to show starts out as the default tab. And here it's the event target. That's our mistake right there. We shouldn't be saying event.target. What we should be doing is saying tab element. Because we're looping through all the elements that have IDs on it. We're adding the event listener to the tab element, and then we should be saying show that tab element. Instead, what we're doing is we're saying show the thing that was clicked. But what's actually clicked is the link inside the list element, not the list element itself. So I bet you if I do that, that will fix it. It does. Look at that. Now it's working just fine. Excellent. But that's not actually what we want to do. We don't want to fix it. I only did that to prove that we knew what the problem was. What we really want to do is test drive the solution for this. So let me go ahead and commit what we've done so far. So we've improved the fail fast message when the tab can't be found. Now what we need to do is test drive this. So what's happening here? Well, in our index.html, we're clicking this, which is inside of the thing that has the ID that we're actually passing in. So we need to reproduce this. So let's go to our tests and write a new test. Use a class to hide all content elements, styles the default tab, switches content when tab is clicked, preserves existing classes when you're adding new classes. I think I'll add a new test right here, which says that it switches context, handles clicks of elements, of sub-elements within tabs. Yeah, handles clicks on sub-elements within tabs. That's what we're doing, and that's what we didn't think of. So if we're next, remember we're going to get to root cause analysis. I think part of the root cause or initial thing to think about here is that we assumed that we'd only be dealing with the element that we're passing in. We didn't consider that there might be additional elements involved. So how can we write this test? We'll need to add a new element that's a little more complicated. So let's do it this way. We're going to need the default tab, and then we're going to need a complex tab, that's going to have within it a link. And then we'll need some content, which I don't think we care about. So I'll just say initialize. Our tabs are going to be default tab and complex tab. Content is going to be whatever. Tab content, tab content. Our default tab is going to be the default tab. Our active tab class is going to be our active tab, and our hidden content class is irrelevant in this case. And what we want to do is actually click this link. So let's give that an ID, call it link, and let's make a variable called link. So we'll get that element by its name, and then we will click it and assert that the tab is active. Now, if I've done this right, this should fail with the same error that we got before, could not find tab and tab to show. Because what I'm doing here is I'm creating a default tab, I'm creating a tab, a regular tab, and then I'm putting inside of it this link, pulling a reference to the link element out and clicking that link. That's basically what we're doing here when we're clicking these links. So let's try that. Perfect, 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 perfect. Could not find tab to show. There we go. Oh, fantastic, fantastic. So now we can fix that. And the way we fix it is right here. Instead of using event.target, we want to talk about the element that may contain the thing being clicked. So what happens in JavaScript is when you click something, if that something doesn't handle that event and stop it from propagating, then it will bubble up to the containing elements. But when we say element.target, and And this is a little hard to explain without diagrams, and you can find diagrams in this lesson learned video right here. But what's happening here is that the event listener for click does fire even when elements within our tab are clicked. So even when this A reference is clicked right here, this list item element still gets the click event unless you do specific things to prevent it from happening, which we're not doing. So we're getting the click event on our list item element, but when we say show tab, we're saying show the element that was the target of the click, and the target of the click was the thing that was originally clicked. So what we need to do is change this to the element that's actually doing the listening. And if we do that, the test passed. Fantastic. Okay, let's check that in. So we fixed our bugs. Now we can use nested elements in our tabs. And that hopefully is now working. And there we go. It is working. So we found the bug code, we reproduced the bug with a test, and we fixed it. Now we need to look at the design of our code. Is there something about the design of this code that made this bug more likely? Well, it was all isolated within this handle clicks function, and this handle clicks function is pretty small and straightforward. Really what was happening here was a misunderstanding of the event, event.target, using that instead of tab element. We were being a little fancier than we need to be honest. Other than maybe taking that event out, I don't see much in the ways to improve this. So I'm just going to do that. In fact, I'm just going to amend our previous commit. And the design's pretty good, if I do say so myself. So I think that's good enough for now. Now for root cause analysis. Why did we have this bug? Well, we had the bug because we thought that we needed to do event.target instead of tab element. But why did we want to do event.target instead of tab element? Well, honestly, it's because I wanted to show it to you. I was showing off features. We weren't being as simple as we needed to be. But I think there's another reason there too, which is that I simply didn't realize that there was a difference between event.target and tab element. So why didn't that occur to me right away? Well, the way events work in JavaScript are complicated, and I don't know that I really fully understand them. I've studied them, but I haven't really sat down and read the specification. So that answers the question of why don't I really understand it? I haven't taken the time to dig into the event stuff as much as I should, perhaps. And also, I don't do a lot of work with events. I use them, but most of the time when I'm programming, the hard stuff is in other areas. So I guess the conclusion for this root cause analysis is that I don't understand events as well as I need to. So one thing that I might want to do is go through and really study the events. Now, the question is, and this is something to think about whenever you do root cause analysis will get you to a point of having some solution, but you always need to balance that solution out with the question of how significant was this problem, how likely it is to have a significant problem like this in the future, and is the mitigation, is the thing that you could do to make it better really worth it? For me, yeah, I think it wouldn't hurt for me to spend some more time on looking at events, and I'll try to remember to do that next time I'm doing event-related code. But honestly, this was a pretty small issue, and it was found pretty quickly, so I'm not too concerned about it. Maybe I'm just being lazy. Maybe that's the ultimate root cause. Laziness. However, that's not a legitimate run. Remember, you don't come up with blame, you look at the process. So another way to look at it is, well, maybe I've just got too much stuff on my plate. Could be. Part of the reason I don't want to go off and read the event specification is that it would take time, and I've got lots of other stuff to do with my time. Anyway, that's root cause analysis. Looking at this and thinking, what allowed this bug to occur? For me, I think spending a little more time really deeply understanding events would be a good idea. Or maybe writing more code that works with events so I have more practice with it and got these kinds of defects sort of more firmly embedded in my brain. Now, finally, the fifth step for us to do is exploratory testing for related bugs. One thing that we have here that I noticed, which may be another root cause, is we sort of are doing happy path testing. We only tested a very specific situation, sort of a limited set of things that could happen. And it might be worthwhile for us to go through and test more elaborately. So let's look at our tabs and let's test some edge cases. Let's test what happens when we have lots of tabs and no tabs and duplicate tabs and stuff like that. I'm going to do that real quick and see if we can find any other defects related to the way we handle tabs. So here in our app, we could initialize this with just one tab. See what happens there. Well, all the other tabs reappear, but it does appear to work. They reappear, of course, because they're no longer being eliminated. What happens if we have no tabs? Well, now, okay, so now we're getting an error. Could not find tab to show tab 1, and that's because we're passing default tab through. Really, we'd have a null for no default tab. Yeah, that just causes everything to blow up. So that's something that if we were using this library more, like actually distributing this is something that might be worth implementing. And I'm going to leave this as a challenge for you to think about. How could you test drive a solution to this so that having nothing didn't blow up and actually failed fast in a useful way? Something similar is, what if we have different numbers of tabs and content? Well, that acts kind of wonky too. It doesn't blow up, but it doesn't really behave the way we want it to. And then finally, what if we do repeat a tab? Well, everything's disappeared, but it certainly isn't behaving the way we want it to. Things to consider and I'm going to leave this for you, those of you doing the challenge exercises. We obviously have opportunities to make our tab library more robust. I don't know that any of the things we've found just now are things that we really need to worry about because they're clearly programmer errors. The person who's calling the tabs library is doing it incorrectly. But I do think it's true that the tabs library could be more robust against those sorts of failures. And the interesting thing to note here is how doing this sort of exploratory testing, looking for ways to break the code or at least expose errors rather than just trying to get it to work, can bring an entirely different way of thinking about things to top of mind. Then, of course, it's up to your own judgment whether or not those things are worth actually implementing and putting in the code. For us, I'm not going to do it, but I am going to leave it for those of you who want the challenge exercises. Go ahead and see if you can make this code more robust. And with that, I think that brings us to the end of this episode. We have fixed the bug. We have test-driven a solution, looked at opportunities to improve the design, done root cause analysis, and exploratory testing. Exercise for you is, for those of you following along, go ahead and implement the fix that we did here. And if you're doing the challenge exercises, do some more exploratory testing, look for ways to break the code, and look for ways to make it more bulletproof. Either implement those with simple fail-fast code or even by test driving a full solution. We have one more thing that I want to do in this code before we finish up the chapter, and that's looking at cohesion. Right now, there's a big disconnect between our app code and the IDs that it uses. Next time, we'll look at how to fix that. Thanks for watching. I will catch you next time.